Hey guys, Andre here, founder and director of Appliance Service Masterclass. Today we're getting into the Electrolux Induction cooking presentation. We're going to look at the Induction's history and theory, built-in cooktop, freestanding range, front control, freestanding range as well, and then finally, diagnosis of common issues. Let's just get right into it. So cooking is defined as the application of heat to foods. We have chemical, which is gas cooking using flammable gas. Electrical, which is radiant heat involving resistance type electric elements. Microwave, of course, electromagnetic waves in the microwave. And induction, electromagnetic field generation, utilizing ferrous metal vessels as the conductor. So induction cooking sales and usage, the National Association of Home Builders in 2012 estimated that induction cooktops accounted for only 4% of sales, compared to gas and other electric cooktops. The induction cooking market has grown steadily over the since and is estimated to be about 15% of the electric cooktop market today. And the low-cost freestanding induction ranges are in production and are gaining popularity due to increased energy efficiency, rapid heating, and ease of use. So 1906, we had the first patent granted for an induction cooktop in the UK. Mid-1950s, Frigidaire division of General Motors developed prototype and demonstrated to the North Americas. Mid-1970s, Westinghouse began limited production of the induction cooktops. And about early 1980s, Sears began selling induction cooktops to the mass market. So, electromagnetic induction. The principle was discovered by Michael Faraday in 1831, and Faraday hypothesized that a changing magnetic field is necessary to induce a current in a nearby circuit. Simply putting the magnet within a coil of wire would heat up that coil of wire quite rapidly, actually. The diagram below shows how a moving magnetic field produces a current flow through the coil as detected by the meter. Electromagnetic fields, when an electron flows in the same direction in an electric conductor, such as a metal wire, that generate a cylindrical magnetic field that wraps around the conductor itself. When measuring current flow with a clamp-on ammeter, it is the strength of the electromagnetic field being measured, not the actual current flow itself. The transformer theory will see that the electric magnetic field goes in one direction. So the transformer is based on two principles. First, the electric current can produce a magnetic field, which is electromagnetism. Second, that a changing magnetic field with a coil of wire induces a voltage across the ends of the coil. So this is electromagnetic induction. Changing the current in the primary coil changes the magnetic flux that is developed, and changing the magnetic flux induces a voltage in the secondary coil. The transformer theory here, we see again, magnetic flux, it's going in one direction. Transformers are one of the most used electrical devices in everyday life, yet we are rarely aware of them. In summary, current is induced in a wire when it is exposed to a moving magnetic field. Current flow moving through a wire produces a magnetic field around the wire. And lastly, a short circuit produces extremely high current flow, which in turn produces high temperatures in the current carrying conductors. So how does induction cooking actually work? Well, the induction generator boards power a coil that produces a high frequency electromagnetic field. This field is expanding, collapsing thousands of times per second, creating a movement between the field and the pan. The moving field penetrates the metal of the ferrous metal magnetic cooking vessel and sets up a circulating electric current in the vessel. So this eddy current is the effect of controlled short circuit, which generates heat. The heat generated in the cooking vessel is transferred quickly to the vessel's contents, whether it's water or food or any type of anything that's in that vessel. Nothing outside the vessel is affected by the field. As soon as the vessel is removed from the element or the element turned off, heat generation stops. So we see here in induction delivers 85 to 90% of its energy to the cooktop cooking process. For gas delivers less than half of its total energy to the cooking process. And with that, we see that induction cooking is 73% more efficient than gas. In radiant heating, a properly sized pan or radiant burner has an inefficient heat transfer due to the glass heating first, then the cooking vessel, the pot or the pan. With that, induction cooking is 22% more efficient than radiant electric cooking. We're going to look at today Frigidaire freestanding rear control range. We're going to look at a built-in cooktop, and then we're going to look at some freestanding front control range as well. So first off, we have here the Frigidaire induction cooktop has 4 induction elements and 2 induction power generators. The capacitant touch control system is part of the cooktop assembly right here below. Power supply requirements, of course, we have 240 volt, 40 amp circuit breaker required, max power output 10 kilowatts. So from the bottom, we have 2 cooling fans mounting the generator boards, cool the electronics. The blue arrows show the incoming fresh air, and the red arrow shows heat being exhausted from inside the cooktop, driven by the cooling fans. Exhaust airflow moves underneath the top. Top should not be sealed to the counter, just to ensure that we have enough airflow. When removing the glass top, pay attention to the location of the connectors between the capacitance touch control board and the power board. The induction coils are located directly under the top. The coils are covered by mica to assist with heat management. Cooling coil wire locations on generator boards. So each coil has 3 wires, red, black, and heat sensor harness. Generator boards indicate R for red wire connection. You need to make sure that it's always connected in the proper location. Otherwise, you'll get an inactive component. Below the coils are induction generator boards, each one serving 2 induction elements. A red arrow indicates the wire communication harness between the boards. Each power generator board is equipped with a power management feature designed to protect the electronics. This will not allow use of both induction elements on the max power at the same time. So the last one set up will keep the setting, and the first one set will be derated depending on the heat setting at the time. Here's our rear control freestanding range. We have self-clean convection oven, of course, multi-level adjustable oven racks, hidden bake element, modular electronic oven, 4 induction cook zones, and black ceramic glass cooking surface. The freestanding rear control induction range is built on previous designs and has many common components. Oven bake and broil elements, oven light, convection fan elements, as well as door assembly and storage drawer are just like other smooth glass cooktop ranges. The location of the induction generator boards varies depending on the model. The latest production has the boards mounted underneath the cooktop. This range design is far easier to service than previous models. And this, of course, if you have an Electrolux service contract, you'll notice that you're servicing more of these induction cooktops, and they are, in fact, much easier to service than previous models. The modular electronic oven cooktop control is one-piece assembly that controls operation of the bake and broil, convection, and self-clean functions by individual relays. And this typically is just a non-serviceable part, which means the whole thing will have to be replaced. In addition, it houses the user interface boards, which communicate to the induction generator boards, allowing the user to control each individual induction cooking zone independently. This control is non-serviceable and must be replaced as a complete assembly if found to be defective. To remove the electronic control, the user interface assembly, disconnect the power to the range and remove the upper rear panel. Disconnect the wire harness connections to the EOC and do not disconnect the harness connecting the left and right UIB. Remove 6 Phillip head screws and pull the control back through the rear of the opening. So unlike previous freestanding slide-in induction ranges, this model has a generator board mounted directly beneath the cooktop glass and making them much easier to access for service. The generator board's assembly outer frame serves as a support for the individual induction coils. Accessing these components can be done without moving the range from its installed location. So the cooktop assembly consists of the ceramic glass in the outer frame. Induction components, blower fan, door switch, and door latch can be accessed only if the cooktop assembly is removed. So disconnect the electrical supply range, remove the oven door, remove the 2 screws below the cooktop, and then grasp the cooktop assembly, lift upward, and pull forward. I don't know how many times I've seen technicians fight with this glass cooktop and end up damaging some of the tabs on the side. So it's important to understand how to remove this effectively and to ensure that it's reinstalled appropriately to reduce the risk of condensation. The induction range utilizes a cross-flow fan to circulate air beneath the cooktop when the oven is in use. The primary purpose is to prevent condensation under the cooktop. Okay. This 120-volt fan motor is connected to neutral and L2 out relay on the oven control. The fan only runs when the L2 relay is closed. The cross-flow blower fan is located below the back guard panel. To remove the blower, first remove the cooktop assembly as previously described. After removing the cooktop, remove the upper and lower rear panel and disconnect the wire connections. From the front side, remove the 4 screws to secure the blower to the range chassis and detach the blower assembly from the rear side. Ensure that you're removing these harnesses appropriately and without damaging them, otherwise you will have to reorder a new harness for reinstallation. The induction coils are attached to mounting plates which have metal alignment tabs that insert into the holes in generator board outer frame. Before removing the coil, mark the mounting location of each tab on the generator board. With the cooktop assembly removed, hold the induction coil on frame edge and lift upward to remove the coil. Carefully lay the coil to one side to access the wiring connections. Carefully lay the coil to one side and loosen, do not remove, the 2 number 20 torque screws that secure the wires from the induction element to the generator board. When reconnecting the coil, make sure that the wire with the red insulator sleeve is connected to the terminal labeled R on the generator board, as shown here. Unplug the induction coil temperature sensor from the generator board, no tools required for that, and remove the induction coil assembly. When reinstalling the coil, make sure to maintain the correct mounting position on the generator board assembly outer frame. The induction coils are attached to the mounting plates and have metal alignment tabs to insert the holes in generator board outer frame. The generator boards are mounted to the support plate that is mounted to the range chassis. With the generator board removed, the air intake for the generator cooling fan is visible at that point. Always ensure that this intake is clear of any material that can be restricting for the airflow. The support plate has 2 integral alignment tabs that insert into the generator board housing for proper alignment. Do not bend or break these tabs. Now let's look at the front control range features here. It has self-clean convection oven, multi-level adjustable oven racks, of course, front-mounted electronic oven cooktop control, smooth glass top with 4 induction cook zones. Frigidaire front control freestanding range have a unique air fry feature. The air fry system is straightforward. All models have a 4.5 minute preheat. This is timed and not a true temp preheat. This was done by design as the food should be exposed to the higher temperature of preheat. For the consumer, this means that the best performance for food should go in the preheat. Behind the scene, the algorithm after preheat will continue dumping heat into the oven with the convection element until it achieves set point plus overshoot. And the overshoot is quite high when air frying, 2 to 3 times our normal overshoot. And air fry mode was developed to work with the standard dark cookie sheet and use recipe time and temperature. So no adjustment is needed. For best results, little oil or cooking spray need to crisp and brown air fried foods. So a lot of these service calls that come in within the 1-year warranty for Electrolux ranges really comes down to customer education. And going in as a technician or as a professional, you want to instruct and educate the customer how to best use their appliance, and that will reduce the amount of service calls requested by the customer for non-repair required service calls. The control panel provides the mounting service for the induction cooktop and oven uses interface board, which communicates with the electronic control board to program oven operation, as well as induction power generator boards to activate the induction cooking zones. The user interface is replaced as an entire assembly if any portion of it is found to be defective. So to remove the control panel, access the UIB, open the oven door from the underside of the panel and remove 3 chrome finished screws that secure the panel to the chassis. Once the control panel is free from the range, it can be hung on the bracket tab using the slots cut into the underside of the panel as shown, and this allows for easier access to the UIB communication harness connector. Hang the control panel to the left and right bracket tabs using slots in the underside of the panel. So carefully unplug the two communication harnesses from the UIB and remove the panel with UIB attached. The UIB can be removed from the panel by taking out the 4 mounting screws indicated by the arrows. And make sure that you're disconnecting these harnesses appropriately, or when you do replace the UIB, you want to ensure that these harnesses are being put in correctly and without damage, because again, if you need to replace the harness, you need to also purchase the whole assembly kit. The UIB contains no serviceable parts and is replaced as an entire assembly if defective. The UIB assembly includes the outer frame with overlay, circuit boards, and yellow connecting harnesses, seen in the photo below. To access the induction coils or generator boards, first remove the front control panel as previously described. Make sure to disconnect the 2 UIB communication harnesses. Next, remove the 2 screws securing the front edge of the cooktop to the mounting brackets. From the rear of the range, remove the 3 screws that secure the cooktop assembly to the chassis and main rear cover. It is not necessary to remove the narrow sheet metal spacer strip on the back of the cooktop. After removing the screws, lift the cooktop assembly up and away from the range. Place on a protective work surface just to avoid damaging the cooktop finish. With a glass cooktop, remove the individual induction coils. Induction power generator boards and connecting wire harnesses are accessible. The induction coils have no serviceable component parts and are replaced as an entire assembly again in the event of a failure. Coil assemblies have metal alignment tabs that insert into holes in the generator board outer frame. Mark the location of the coil on the frame for reassembly. To remove the coil, hold near the alignment tabs and lift upward, then lay coil to one side to access the wire connections on the generator board. Unplug the induction coil temperature sensor from the generator board. No tools required for that again. Loosen the number 20 torque screws that connect the coil to the terminals on the generator board and remove the coil assembly. When reconnecting the coil, make sure that the wire with the red insulator sleeve again is connected to the terminal labeled R on the generator board. The 2 generator boards are identical. There are no serviceable parts on the generator boards. They are replaced as an entire assembly. To replace the generator boards, first remove both induction coils as previously described. Disconnect all wiring connections, then straighten the 2 metal tabs that secure the board and the coil carrier panel. Slide the board forward and lift off the chassis. The cooling fan mounted on the rear of the chassis provides airflow to protect the UIB from excessive temperatures. The cooling fan operates during bake or broil once the oven temperatures reaches 200 degrees Fahrenheit and is self-clean whenever the oven door is locked. The air intake is mounted to the rear main cover and secured with a single screw. So the fan is mounted inside a housing that has an air intake at the bottom and extends through the rear main cover. It's important to ensure that there is nothing blocking the incoming air to the fan. To replace the fan, remove the air intake shield and remove the main cover. Unplug the wire harness connectors. Separate the outer half of the fan using housing by compressing the locking tabs. And the fan motor can now be removed by pulling toward the rear. So the cooling fan is not a serviceable part and must be replaced as an entire assembly as well. The modular oven control board contains relays that control operation of the oven elements, oven lights, the door lock, and convection element and fan. It also monitors the oven RTD sensor and the accessory meat probe found on some models. So to access the board, remove the rear wire panel. The board is mounted on the right side of the chassis when viewed from the rear. To remove the board, disconnect all wire harnesses connections that take out the 4 screws that secure the board to the rear of the range, of course. So now let's look at some troubleshooting components. Here we're going to look at the actual induction coil. So we see here in the middle we have the temp sensor, the sensor wires as well, and the coil wires. So the induction coil assembly. And the induction coils are simply a continuous length of wire. To test the coil, a continuity test is all that's needed. So disconnect the coil wires from the generator board and measure resistance between the wires. There should be less than 1 ohm of resistance. The induction coil temperature sensor. Each coil has a temperature sensor that monitors the temperature of the cooktop glass. These sensors are classified as NTC, or negative thermal coefficient, meaning that the temperature of the sensor increases, the resistance decreases. The sensor should be at plus minus 100 k ohms at room temperature. If the sensor is open or shorted, the coil assembly must be replaced in full. The induction generator board. The generator boards contain no serviceable part, and there are limited tests that can be performed on the board itself. If there's any failure in the generator board, there will be an error code displayed on the ESEC UIB. Refer to the text sheet for recommended solution for specific error codes. You should verify that all harness connections are secure and properly connected to each generator board. Follow the wiring schematic found on the text sheet. So when a specific error condition occurs, a code will be displayed in the electronic control panel. Errors relating to the electronic control, oven control will be displayed in the center display over here. Errors relating to electronic surface element control are displayed in the 4 UIB windows, which are left and right over here. All 4 windows are involved. The left window will display the E and generator board involved. Right window shows the actual error code. The example above is the E174, is a showing failure of the left generator board heatsink. For each error code, there's a listing of the likely cause or failure condition, as well as suggested corrective actions to be taken. Always reset the power by disconnecting or turning off the power supply for 30 seconds to see if the failure condition will clear. If the error codes return, perform the steps one at a time in the order listed below to correct the specific failure condition. And that, as we know as appliance technicians, is the service manual tells you precisely what the symptom you're seeing, what the probable cause is, and what the probable solution is as well. And as appliance technicians, we're not going to know all error codes and faults for each appliance on each manufacturer. And, just being resourceful as an appliance technician allows you to accurately and troubleshoot and diagnose appliances based on the service manual from the manufacturer themselves. So, technical data sheets. The fault codes beginning with F relate only to oven components. The F10 is a runaway temperature. Oven heats when no cook cycle is programmed. F11, we see a shorted keypad and selector switch. F13, the EOC internal software error or failure. F14, keyboard tail failure. F30, open oven sensor probe circuit. F31, shorted oven sensor probe circuit. And then F90 through 95, door lock motor or latch circuit failure. You want to consult the technical data sheets for information regarding fault codes, circuit matrix, and RTD sensor values. Fault codes beginning with E relate to service components. We have E001 is an internal error, all the way through E248. Again, consult technical data sheets for information regarding the fault codes and the circuit matrix RTD sensors. And what we like and appreciate about the manufacturer's service manuals is they'll tell you the error code here, likely cause or failure, and then suggested corrective actions. And again, as a technician, it's imperative to understand that you're not going to know all error codes and fault codes and diagnostic processes for each appliance, for each manufacturer. It's important to stay resourceful, to be able to find that service manual and actually be able to look through it to find the answers you're looking for. And each manufacturer has a service manual for each product they put out into the market that have suggested corrective actions. So, circuit analysis matrix contains data regarding relay operation. It shows which relays are involved with individual cycles. Modular control algorithms control when relay is activated. So we see here for the bake, we have L1 to bake open, L1 to broil, L1 to convection, L1 to and nothing after that. For convection, we have L1 to bake, L1 to broil, L1 to convection, and L1 to convection fan, L1 to convection indicator light as well. So being able to understand how to read these will assist you to troubleshoot and diagnose your appliances appropriately and be able to finish a service call, hopefully in 1 to 2 visits. Many times electronic controls and other components are replaced unnecessarily because the incoming power supply was not verified by the technician. So when testing the electrical supply, the test should be performed at the terminal block where the power cord or housing wiring attaches to the appliance. So you want to verify that there are 240 volts between L1 and L2, that there is 120 volts from L1 to neutral and from L2 to neutral. And we have that noted over here as well. You should also check the power supply while the appliance is operating or under load. The power supply may show good with the product sitting idle, but fail when the certain components are turned on. So this can be caused by a weak connection in the customer's house wiring, or a faulty circuit breaker or fuse. So a safety note here, of course, we have to mention, use extreme caution when testing equipment live. Serious injury due to arcing, unexpected component failure, or short circuit events can occur during live testing. So you want to be careful. Our final notes here on induction cooking concerns. Humming or buzzing noise during cooking. So ferrous metals, that's magnetic. Cooking vessels have different iron content and design. Due to variations in cookware, audible electronic magnetic noise or humming or buzzing may be produced by exposure to magnetic fields. So try a different pan if the problem is objectionable. High-pitched whining or whistling noise. Cooking vessels which have cladding or layers are sturdy. Construction such as cast iron are less likely to generate these objectionable noise. Changes in the size or volume of the food cooking content in the pan can affect this. Overheating or uneven heating. So the size and strength of the magnetic field is determined by a combination of the coil size and generator board setting. The pan must be made of ferrous metal and the appropriate size for the cooking zone it is placed on. Slow cooking performance or burner shuts off. So a mismatch between the cooking vessel size and the induction zone is the main reason for the concern. If the generator board does not sense current flow, it will shut off. And the EMF radiation and pacemaker safety concerns. So there's a controversy surrounding these issues. Induction cooking generates short wave RF radiation of the non-ionizing type, less than 1 foot in length. So unless you're sitting in the pan, possible exposure to damaging RF radiation is virtually non-existent. Although we do have to note, persons with a pacemaker or implanted medical device should consult their physician and avoid induction cooking devices based on their assessment of the risk. And that's what we have here for the Electrolux Induction Cooking presentation. If you're interested in learning more about appliance repair or building your own appliance business, applying to manufacturers like LG, Whirlpool, Electrolux for your own service contract, continue to join us at Appliance Service Masterclass. Click the link below to book a call with any of our professionals to see how we can help you grow your business today. Thank you for joining.
Here at Appliance Service Masterclass, we're a small team doing big things. Make sure to purchase the Appliance Service Blue Book with the link below to empower your business today.